Oh, thank you everybody for joining me for quick wins with the PS framework. Before we get started, a big shout out to our sponsors. Without them, nothing of this would have been possible. Thank you everybody. So, I'm Fred. I'm Cloud Solution Architect. I'm working at Microsoft and I'm, busy doing different things, mostly gaming, reading, bartending, and, bragging about my toys, at least when I'm not on the job. And, there are a few toys to brag about, and usually I try to keep them out of my sessions, at least too much of that bragging, because that usually means I tell you, you can only do this when you're using my toys. But today's session is going to be a slight departure from that, because this is all about PS Framework. PowerShell framework, PS Framework, is something people usually think about when they hear logging. It's most known flagship feature in all of the module. It has a lot of more. The main purpose of PS Framework is to make it easier for me to write high quality, good readable code than it would be to write bad code. So there are a lot of improvements, upgrades over the default coding mechanisms that we would be using. And we'll be looking into how can we gain something for scripting with minimal effort. So this is all the slides I have. I hope you can forgive me for that. I know it's a dear disappointment, but down the luck. You can find lots of documentation at psframework.org. I try to document the whole thing because some of the features are arcane, require some deep dive understanding of what's happening there in order to use it properly. We are not talking about those features today. But that also means that the online documentation can feel kind of clunky because it's focused on explaining everything, not focused on how the hell do I get the best use out of it as in a short time as possible. Again, that's why we're here. So, it's well known for logging, so we'll start with how the hell do I get logging done real quick. And it all starts with this nice little command called write PSF message. It sends a message to the log, whatever that happens to be. So there it is, gone. Message has been sent. Where? Well, for now we can use the -variable switch in order to get the variables message. So there is the usual streams are being used. So if you're already using transcript logging, that's going to be in there as well. We also have the level parameter to define different levels at which we can write log messages. If we specify the level host, that's going to be written to host. We also have a few additional levels. Not all of them are equivalent. For example, we have somewhat verbose. We might have also very verbose, or something like even an internal comment. They don't match the regular message levels that we use from logging, like info, debug, and error. Info, debug, warning, error. It's a bit more granular. We have a level range, and the level range mostly determines how likely it is to written on screen or to the verbal stream. It has no effect initially to the logging. We can, however, specify log levels in the filter later on. Exception kind of is warning and error. They exist independently and they will always be shown. So, where did they go? These messages go first of all to an in-memory queue. So everything is still there. And if you're taking one of them, select object first one and show the list view, there's a lot of information here. We have message and log message. I'm not going to go into details on that, but the PS framework supports localization. So warning messages could be in German, in English, in Italian, in Chinese, and whatever. And the log message would still be written in English, no matter what the display language is. That's one of those deep dive features that require a bit more explanation than we're going to invest today. Other than that, we have tags, extra data, and a target somewhere, which allows us to add metadata for tracking, for later log analysis. What everything happened to that user? What happened during that step? We can track that. We also have the script call stack in case of troubleshooting, and most notably, run space. psframework logging happens in a dedicated background run space, and when you multi-thread in PowerShell, you can write log messages from anywhere without having any write conflict wherever you're writing to. So that works well. Has some problems because if the logging happens asynchronously, on the one hand, we don't have any script performance loss because we don't have any latency until the logging call is done. So that's good. But it also means a script might be completed before the logging has been completed. So we might need to handle that, and there might be a command for that, coming back to that. So we now have a log in memory. We also have a default debug log under app data for 7 days or 100 megabytes, whatever happens first. Automatic log rotate, just in case. If we now want a dedicated log file, there are different ways to do this, but the simplest one is a command called setPSFLoggingProvider. I want a log file. There are built-in options for Splunk, Graylog, SQL database, event log, console, Azure Log Analytics, whatever we need. And you can build your own plugins if it doesn't serve. But log file is the most simple one. Instance name is kind of optional, but it helps avoid conflict if I have multiple logging configurations enabled at the same time. The path I'm logging to, and it should be enabled. So let's run this. Write the message. Oh, come on. Yes, of course. It worked. I'm just kind of silly about this one. So let me fix that for demo purposes. %date% means the date is automatically inserted, and if we switch over from midnight to the next day, it will automatically switch to the next file. This is mostly because there are non-dynamic ways to provide the thing like config files, and in config files you can't run get date. %date% will automatically handle that for us. So there's the log message. We can, as mentioned, also include a tag. And somewhere in here, there is now the tag greeting. There we go. Now, as mentioned, we can have multiple settings configured at the same time. And I simply call another setPSFLoggingProvider and change the instance name. In that case, I can have multiple log files. I could, of course, also then choose as a second option to write to event log. Not all of that. There we go. Writing a second message, another message. This is going to show up here. It did. But log file 2 is still empty. It exists. We didn't get an error, but it's still empty because we added something here. At the end, I added a filter. Only messages with the tag greeting are supposed to go there. So let's write a message with the tag greeting. It's in here. And here we are. Yeah, and finally, there's this command called readPSFMessage that is going to log your console until logging has completed. I have put an example script together for like end-to-end everything, where we have here at the beginning the error handling. The trap statement, something new, or do you already know about that one? The trap statement is a global try-catch for everything that happens afterwards. So in case anything in the script breaks, the trap statement is going to execute. And with that, we do a final logging message. It failed. We can't provide the error record. And we wait for logging to complete before we finally pass on the error so the task scheduler can realize the script failed. And the rest of the script is, well, set PSFLoggingProvider to configure it, and then sending some messages along. And finally, here at the bottom, wait PSF message, because the wait PSF message in trap only fires if the script failed. That's a sample script on how we would do the logging. Well, Last thing about the whole thing, the entire logging is driven by the psFramework configuration system. Not going into that. There's a extensive documentation on that. But basically, you can define logging by group policy. You can have a dedicated config file. You can have environment variables. So you can change the logging of a script without having to modify the script. Very convenient when we're looking later into secure code design secure code design practices in the next session, where we kind of don't want to change the script file. So, logging. That's it. Moving on to a slight little thing that we have in our scripting life basically since day one. I'm going to create a custom object here. Gonna name it Fred and give it a few numbers. So, object has two properties. One of them is an array with two values. And what we're going to do now is we're going to convert it to CSV. You probably already experienced that one. Oops, system.object, open square bracket, closing square bracket. Export CSV classic number 1. Now we have to go and somehow fix this, which probably is going to involve a for each loop and trying to combine the values into something useful. Or it might involve psFramework. Convert from PSF array. And of course, there is a property, parameter to determine just how we're joining the values. Warning, this is not an optimized performance thing. It will go for every object you pipe to it, check for every single property, whether it is an array, and then join them. So this is not something that is going to scale to hundreds of thousands of objects. At that point, you're better off doing a custom optimized implementation yourself for each loop. But for convenient console experience, for a quick script where we know it's never going to need to scale, well, makes it a lot simpler. And that's all there is to this command. So let's move on to the next quick win that we can take away. And that is one of my old nemesis. We need a bit of data for that. So I'm going to grab all the files, child item, path, C, Windows, file, force, give me all the files, even the hidden system files. There we go. So let's say we want a report about name and size of the files. If we want to export this to CSV, we usually have to select object in between. So let's do that. Select object, name, length. There we go. Unfortunately, my manager comes back to me and asks me, no, Fred, I wanted a size report. What the hell is this length thing? So let's rename that property. For that, we have this nice notation in select object, where we define a new calculated property with a name and an expression that determines how that's supposed to look. And now we've got size here. Of course, this is nice and all, but Fred, actually, I want some human readable numbers, not literal bytes. Gigabyte, megabyte, kilobyte, some better sizing would be appreciated. We can do that. But at that point, we start getting into hot waters. I'm going to a simplified one here only. The format operator inserts the values on the right side into the string on the left side. Open curly braces, index number, closing curly braces determines in which order they are inserted. And this colon and the format assignment determines how it's being displayed. In case of numbers, this means we're trimming it to two digits after the comma or the dot, depending on what locale we are at. Nice. Only some of them are kind of unwieldy from a sizing perspective. And honestly, if we are now trying to get the proper size for each file, the script bug is going to turn really ugly. So, psFramework. Let's do the same thing in psFramework. Select PSF object. Name, length as size. Wrong window to scroll. Rename done. Let's make this look good by type converting it to the type PSF size. And while we're on the topic, there's still numbers. But we can do better than just that. We can access sub-properties. Or we can, where did I go wrong? That's right time. Get date. Okay. Damn demo gods, that one worked literally yesterday. There's apparently some... yeah, of course. Shame is my name. It's of course a toString method, not the getDate method. Well, select PSF object allows us to basically skip all of these calculated expressions. We can also provide them, so we can mix that if one of the predefines for some more complex calculation just doesn't do the job. So it does do both. It's input time calculation. It converts those expressions into those hash tables for us. Under the hood, it's still calling select object, but it's basically zero overhead since we're only doing a one-time conversion at the beginning, so it has pretty much the same performance signature as select object. So this is something we could use in a scaling script. So, hash tables. Hash tables are a great thing, especially when we're using it for splatting. So let's go with a simple one. I've got a path, which happens to be z. I've got a force, which happens to be true. And I really appreciate how often force and violence are an answer in PowerShell. So fire, get child item at param, and you're good. Oh, it inserted code, but doesn't matter. Still works perfectly fine. So let's say, however, our hash table has a problem because, you know, there is also a third value in there that doesn't belong to the child item. If you're trying to do this now, it's trying to match this to a parameter called answer and doesn't exist on getChildItem. So let's fix that by using convert to PSF hash table reference command getChildItem. We're telling it for which command is this hash table intended. And with that, we can now call that. Because this now only retains the keys. Important part about convert to PSF hash table, it takes input hash tables, it accepts input objects of any kind, and it also accepts the $ps bound parameters system variable. So if you want to just pass through a few of your parameters to an internal command, well, ps bound parameters pipe to convert to PSF hash table, and that's it. Okay. One of the key reasons I wrote psFramework is I'm so bloody lazy. I don't want to invest too much time, which means I want user-friendly code. That helps me. But I don't want to spend the time writing it. And one of the key features about, well, user experience is type completion. So first of all, we need a command that we need to complete for it. It needs to be absolutely business critical, so we all see the severity of the situation. There we go. And I now want to, well, have something to complete here. It's just not really helpful. So I still need to type manually, and you saw I didn't even intend to do this typo there, and it happened. I've got an EA weakness, so sometimes I'm just typing A when I should be typing E and the other way around, which is highly annoying, but in this case it served the demo. So we want to insert tab completion here. Classic solution for that is, let's do a validate set. The problem with validate set is I need to know the legal values at the time that I'm writing the code. But the legal values might change depending on what's in my fridge. And I'm going to go to the supermarket tomorrow. Kind of running low there. So we need to have some dynamism here. And if you're looking for dynamic tab completion, most Google results are going to send you towards dynamic parameters. Please do not use them for dynamic tab completion. This is just a high match quality because, the dynamic word. What we have with psframework here is the ability to first define a script block that is going to calculate the legal values, and we need to assign it a name. The script block could be doing REST API calls, could read text files, could have an in-memory cache, whatever we want to do. So we assign it, we create it, and then we need to assign it. Tell the PowerShell which command on which parameter is supposed to be using that. And that's it. Get alcohol, type. So that's nice. There's one more feature or problem here. This is only tab completion. In opposite to validate set, I'm still allowed to provide values that are not actually part of that original list. So I'm now ordering a mojito, and it works. I mean, a picture of mojito is kind of a challenge, but one I'm willing to take upon me. Now, however, the problem that sometimes maybe accepting not expected values is a bad idea. I mean, imagine you're the bartender at the company event and the CEO orders his favorite drink and you tell him, yes, of course, only to later not have the ingredients. That's probably raise some expectations that come back to haunt you. So we want some validation actually here. Okay, we want some validation. So let's go in here, add some PSF validate set, which does the exact same thing as validate set, only it has one more parameter called tab completion, which can understand those tab completion logics. So, updated, and meat is still perfectly fine. Mojito is no longer on the list of legal values. And this tab completion can have an integrated caching, so the values are calculated once and then remembered for 8 hours or so, because let's be honest, our domain controllers don't change that frequently, so we don't have to pay the performance cost all the time. Now, there is, however, one more thing, and that is we have a second parameter here. And let's just be honest, picture is not always the perfect size. So we kind of want tab completion that reacts to other parameters. So, new script block that we are registering under the name alcohol.maxSize. And based on what it was bound to the parameter type already, it offers a different set of values. This variable, fake bound parameter, exists automatically in all completion script blocks. You can just use it. We assign it. Get alcohol type meat unit horn. Now, this is nice, but sometimes we might have trouble understanding just what meat is. I mean, some culture groups that would be self-explanatory. For my Japanese friend, that might be something strange. So we, of course, want to add some additional details to the completion. So let's do that. And there we go. Still one of my favorites. I admit I wasn't being quite that lazy when I wrote that system. But again, something that makes my life a lot easier since I have that. So, big fan of that. Okay. Here's a classic command that I see turning up in customer scripts. I want to get some information from those computers, so I accept computer names, and then I'm sending that to invoke command and getting that information. We have a major code design flaw in this code right now, as it is. What we should be doing instead is this. Invoke command automatically includes parallel execution if we give it a choice. With the for each loop, we force it into sequential one after the other processing. If I give it all the computer names right away, it's going to ask all of the computers right away. But still, this has a few problems here. We want string. What happens if I give this command an Active Directory computer object? It's going to fail. It can't resolve the name because when I convert an Active Directory computer object to string, it's returning the distinguished name and not the DNS name. Or SQL Server, or a completely invalid host name, or an already established PowerShell remoting session. So this is a bit annoying. So there is a nice parameter type called PSFComputer that solves all of that. Now, an Active Directory computer object is going to work, a PowerShell remoting session is going to work, everything's going to work. Well, not quite everything, but you can even train your own custom input objects for this. I'm not going to go into that detail. But with that, we can now pass all of that through. Only problem is if I now provide a PowerShell remoting session, already configured with proxy settings, credentials, and whatnot, invoke command expects a string for computer name. So it's going to destroy the session, pick up the computer name of the remote computer, and try to default connect, which is not going to work because there was a reason we did all of that pre-preparation. So if only there were a simple way to just pass through this whole thing. Unfortunately, we're not. Okay, yes, it works like that. That's all. Well, just a little bit to make my computer targeting easier. There is a dedicated documentation page that goes into more details. For out of time reason, not going to go into the full execution and proof of concept on that. Only one quick part here. This is going to work. A white space is not legal. A SQL Server connection string is legal. An IPv6 localhost instruction is also legal, and it can also tell us that it is localhost. So parameter classes is one of my favorite features in psFramework because I just like the wizardry behind it. It's such a magic black box that I can wow people with, including myself, after I forgot how I did it, which happens a bit more often than I would like. But that's how it is. So I've got one more parameter. Okay, I've got a few more parameter classes, but one more that is going to change the way you code. For other things, it's the other parameter classes are kind of conveniences. So you can do a timestamp of 8h, and it's gonna 8 hours into the future. So that's somewhat trivial. What we have now is a classic command as we keep writing it if we're doing it right. I want to read multiple files, so I accept a string array of paths. Now I need to resolve these paths. In case of error, handle that. Then for each resolved paths, I need to verify that it's actually a file, a leaf, and not a directory, because I can't get content on a directory. And finally, if that worked out, I can do something with that path. So let's do that. And I can now path ctemp demo wildcard. And it complains correctly that that doesn't work because I kind of got the slash. And there we are. So let's do the same thing, like the absolutely same thing in psFramework. This parameter class takes all of that input interpretation off our hands. And in case we have this literal path thing, if you want to use both, that is also a highly complex operation. In case you're wondering, literal path doesn't interpret wildcards. Path interprets wildcards. There's a problem with that we rarely encounter, but square brackets are wildcard special characters and legal file names. So sometimes path actually doesn't work, which is why I have literal path. So that's also a possibility. Also highly frequent, we want an output path, which is a path to a legal file system where the file doesn't exist actually. So we can't really validate with test path, can we? So PSF new file handles this for us. And this is going to work. This, not so much. So this parameter class accepts a single string to either a file, where the file doesn't need to exist, but the parent folder needs to exist. And it's going to fully resolve it into the full name in case you need to pass this to a .NET method that actually doesn't accept literal paths as PowerShell system. Yeah. No, we are at the time benchmark where we're supposed to start with the Q&A. Anything you want to ask, or should we just continue? Because I have definitely about 1 hour worth of material extra than we would need intentionally. So, anything so far? Okay, let's continue. In that case, there is one of the classic problems in our coding. We know how to safely and cleanly document and execute code. With proper what if and confirm, it just usually is such an effort that we don't bother, that we just can't justify it most of the time, because this looks kind of like that. If should process do something, then we try catch the whole thing. Then we are saying, hey, I'm attempting this, logging that, performing the attempt, we log that it worked, or in case of error, we log that it didn't work, produce the error, and continue on with the next item. This is reasonable, and it works like this. Let's do the psFramework version. Same code. So let's remove filelet. And I know that I am not actually validating things, and I intentionally didn't use the parameter class because the parameter class would be breaking the demo here a little bit. But let's remove my fake folder. One of these days, one of my coworkers is going to catch my device unlocked and create that folder only to troll my demos. I know it. It's going to ruin so many demos of mine if they do that. So, failed to delete didn't exist. Okay. Since we have multiple messages in here and we're only showing the failing warning, we have some preliminary items. And I can also ask it for, do you really want to do this? In case of what if, it just pretends to. In case of confirm, it's going to ask us. So that's already nice and useful, but we have more in that. I'm going to grab that, and I'm going to tell it retry 3 times. And retry, wait only 1 second between each retry. There's also an option to wait in increasingly amounts of time each time you fail. So let's do this again. And that is something I extensively used during the Active Directory Management framework because I had highly sensitive things happening, so secure handling was required. But I just couldn't be bothered to write try catch and all the other handling around that manually. So I did it once in invoke PSF protected command, and that's basically a wrap around all of that. So, next fun. We have got some files here, and I'm going to export them into a CLI XML format, which I can then later read from PowerShell with import CLI XML. Easy enough to do. Import CLI XML and export CLI XML are intended to transport PowerShell objects from PowerShell to PowerShell. So, files.cli XML, file extension actually is not important. And I should be doing the export because, yeah, that's going to work out slightly better. And now I can import CLI XML then. So far, this is simple enough. It works. We get the same formatting. Great. So I went ahead and decided I can do this better because, no wheel is better than the one that I reinvented in Shiny. So there is now also export PSF CLI XML. Okay, Fred, that was not smart. I might want to keep a different extension to do comparison afterwards. And I now try to import PSF CLI XML this. That's exactly the same thing. So what the hell is Fred talking about? Why the hell did he have to reinvent that wheel? I mean, there are greater challenges to take, aren't there? So give me files.wildcard. These files contain the exact same content. There's a slight difference. CLI XML is XML. XML is fairly wasteful when it comes to storage space. The only things that psframework export PSF CLI XML adds on top is integrated string compression. So I take the same serialize. I did not implement my own object conversion here. I'm taking the PowerShell object conversion, get that XML string in memory, and then I compress it. Usually the command is also faster because the bottleneck is disk I/O. When I'm writing a gigabyte of data, it takes a bit of time. So that's all there is to this command. I write a script, I give it a coworker, and I go on vacation. 1 week down the road, that coworker sends me an email, your script broke. Here's a screenshot. Of the red arrow message. I'm kind of grateful that I even get that much, but real debugging data that helps me actually troubleshoot the problem would have been great. I would really like that. But it was not meant to be. So I added something to fix that. It's called new PSF support package. I can tell it where to write the whole thing, but if I don't tell it that, it's going to drop a zip file on the desktop of the user. And it's now started gathering up and collecting information. And I probably had some double execution here, which is perfectly fine. So, what is in that file? How do we access it? It's a zip file, so there's expand archive. And I'm going to grab one of those, don't really care which. And I'm going to expand this into the current location. And that is also the reason why we had the PSF CLI XML things going on here, because we now need import PSF CLI XML to read the file. And there is now a PowerShell support pack.cli dat. So what's in that? Well, for one thing, the one information I usually need the most and get the least what actual modules are loaded. In which version it's the full module object. I can check for module base from which path that they loaded. So it's all in there. I also have this thing called history, which is kind of nice, which it also includes the timestamps behind the scenes, so I see when exactly did they do this. We have PowerShell errors that happened. We have the messages that were logged into memory, so up to the last 1024. And we have, well, lots of other things, including a screenshot of the console window. All included in that package. The assemblies that were loaded, the PowerShell version, the CPU, the memory, the operating system. Lots of debugging information to help us. And if you want to write a module, there's also a command to add additional debugging data from your module. So that helps me get useful, actionable data. And it helps a lot, especially on customer projects where they have some problem with the project. While I'm busy delivering in a workshop and I just don't have time to look into things, they can't really send me the data, but they can create a debug dump. And the next time I'm at the site, we can look at it together. It's just a way to snapshot the state, because how often do we have it? Hey, there's something not working. And by the time you're back to try to test it, it works again. How often is the import sequence of modules relevant when it comes to Azure authentication or something like that? That's where the support package comes in. Another classic in scripting. We have a script intended for an interactive use, and we need to ask the user a question, like giving him a choice of things like a menu. So let's give them a choice. Ask them the question. And there we are. We can also change this whole menu thing, going vertical, in which case we get index numbers. Don't be confused about the return value here. It's giving us the index position of the option, and we start counting at 0. So the first one is 0. This uses the default PowerShell interaction API. So if you're in an unattended session, it's not going to hang the console like read host would. It's instead going with the default option, which this time is the first value. There's a parameter to change that. Well, let's skip that one and go straight to throttling. One of the problems I have of working with the Graph API is that sometimes they believe that I'm being too greedy and slow down, Fred, don't go quite that fast. Like only 100 requests every 60 seconds. Annoying, but it is what it is. And there's a PowerShell framework tool to fix that. Not the limit, but making it easier to use in your code to limit without running into it. And that is the new psframework command. It takes an interval, let's say 10 seconds, and a limit, let's go with 3. 3 counts every 10 seconds. And we then call, whenever we want to check for the throttle, like, can I go again? We just hit get slot. This is going to work well the first 3 times. Now all 3 times are consumed for the 10 seconds interval, and we have to wait. The console is going to pause until that time has expired. We can also add another limit of, let's say, every 5 seconds, only 2. And since this is a method, I need to put that in quotes. And now both limits apply. And the first one that is hit is going to pause things. So now it's paused on the third execution because the 5 seconds limit has expired. And it returns. And now that I hit the next one, I hit the other limit, and it's going to have us wait that far as well. Yeah. Temp files. How often do I need some temporary items in PowerShell, like some temporary folder to gather the email together that I'm going to send or whatever? New PSF temp directory. I don't need to specify anything. Oh, actually, I do need for cleanness my script. And I'm going to give it a name foo. So this is my path. And it exists once VS Code is willing to operate. And when I'm done at the end of the session, I can just run get PSF temp item. Come on, VS Code, bad time for it to crap up. And there's also a remove PSF temp item. And that just now removed the folder. So this is now going to error out. It also removed all the contents I dumped in there. And well, with that, temporary items are handled. The same exists for files. And there's an extensibility if you want temporary Azure user or temporary SQL databases or temporary whatever. You can extend that. I kind of got all in on this extensibility thing I already talked about in the previous session. Yeah, it's 9:45. The time has run out, the content not. You know me. I will be always happy to brag a bit more about my toys. I hope you took some value out of that with today's session. Thank you.